In this video, I will be doing a couple examples where I solve a rational equation and I will be doing it algebraically. So here's my first example down here of a rational equation, and I will be following these 5 steps that I sometimes refer to as clearing the fractions method. It does assume you know how to find a common denominator of an expression that involves variables. So for example, it says identify the common denominator of all the fractions. You can think of the number 4 as a fraction if you read it over 1. So this denominator is 2x plus 5, and this denominator is a 1. So my least common denominator would simply be 2x plus 5. Step 2 says, take note of any values of x that make the denominator 0. Those x values cannot be used as solutions to the equation. What that means is when we're done with this algebraic process, any x values that would make your denominator 0 won't check because division by 0 is undefined. So that'll work itself out when you check your work by substituting at the end. If you end up having a value of x that makes the denominator 0, then they cannot be used as solutions to the equation, because how could they? There's no way that upon substitution such values would yield a true statement, given that when you divide by 0 it's undefined. So for example, whatever makes 2x plus 5 equal to 0, and I can find that quickly if you want, you can subtract the 5 over and divide the 2. So it turns out if you were to substitute negative 5 halves into this equation, your denominator would be 0. Your numerator would be some other number that doesn't really matter for purposes of my argument. The idea is, since that x value makes the denominator 0, this cannot be a true statement because division by 0 is undefined. And if it's undefined, how can we say it's equal to 4? So you can either set your least common denominator equal to 0 at the beginning of the problem and be aware of such solutions that make the denominator 0 and know they are not possible solutions to the problem. So now I know x equals negative 5 halves is not a solution. Or you can just wait to check your work at the end, and if you end up getting a 0 in the denominator, it won't be a solution. So I've done step 1. I've identified my common denominator. I took note of any x values that make my denominator 0. Now it says multiply both sides of the equation by the least common denominator. So let me copy the left-hand side of my equation down. Leave some room to do that multiplication. I'm now going to multiply both sides by my least common denominator of 2x plus 5. So on the left-hand side, I multiply by 2x plus 5. And for some students, it's helpful to think of that as over 1, so they realize that's in the numerator. And since I multiplied the left-hand side by that factor, I must multiply the right-hand side by that factor. Notice the use of parentheses here, which shows that the 4 actually gets multiplied by both terms, not just the first one. Now in mathematics, it is not legal, so to speak, to cancel terms, but you can cancel factors. For example, this 2x is being separated by the 5 by addition. So that makes this 2x right here a term, much the same way this 2x is a term, meaning it is not legal for me to cancel this 2x with this 2x. But if I put parentheses around this 2x plus 5 and this 11x minus 7, that illustrates that if you think of these sets of parentheses as individual items, they are factors, meaning everything is being multiplied or divided. In that case, you are allowed to simplify out. 2x plus 5 divided by 2x plus 5 is the same thing as arguing what 7 divided by 7 is. A number divided by itself simplifies down to be the number 1. And it turns out because these are the same factors, any number you plug in for x, you're going to get the same number on the top of the fraction as you do the bottom. So this really is a number divided by itself. So oftentimes as teachers we say they cancel, we really should be saying that that simplifies down to be the number 1, much like 7 divided by 7 is 1. So you would have 1 times 11x minus 7, but since we don't write multiplication by 1, we leave that off, it appears that these just went away, hence the word canceled. Now on the right hand side, I have 4 times 2x is 8x, applying what's called the distributive property, and then you distribute the 4 to the 5 and say that 4 times 5 is positive 20. There was really no need for these parentheses here. This is nothing more than 11x minus 7. Notice that when I multiplied both sides of the equation by the LCD here, everything had a denominator of 1. Or if you want, there's no more fraction, and that's why we call this clearing the fractions. So this will clear the fractions. As long as you multiply both sides of the equation by the LCD, which we did, it will clear the fractions, and now we have just a linear equation which you should be able to solve. So I'm on step 4, solve for x. because I like the coefficient on x to be positive, I'm going to choose to take the 8x on that side because I know 11 minus 8 is positive. So I will subtract 8x on both sides. 11x minus 8x is 3x. 8x minus 8x is 0, and we don't write 0. Sometimes we say that cancels. So on the right-hand side, I just have 20. To solve that equation, I'm going to simply add 7 to both sides. Negative 7 plus 7 is 0. 20 plus 7 is 27. The 3 is being multiplied. So to take it to the side, I will divide by 3. 3 divided by 3 is 1. 1 times x can just be written as x. And 27 divided by 3 is just 9. Since my result isn't the number negative 5 halves, it's likely going to check unless I made some mistake here. So let me take the original equation and just check it. So I'm doing step 5 here that says check your work by substituting the value back into the equation. So here's my original problem, and I need to replace the variable x with the number 9 because 9 is the result we got from that algebraic process, and we will see if that makes a true statement or not. So does this stuff come out to be 4 or not? So let's see here. 11 times 9 is 99. 2 times 9 is 18. 99 subtract 7 is 92. 18 plus 5 is 23. And now I have to figure out, is 92 divided by 23 4? So it turns out that 92 divided by 23 is indeed 4. If you need your calculator for help, that verifies it right there. So I have the statement that 4 equals 4, which is a true statement, which means this result of x equals 9 is indeed a solution to this equation. What's more is it's the only x value that is a solution to this equation. Let me do one more example in this video. This one may be slightly more complicated because we have 3 fractions, if you will. 1 can be thought of as 1 over 1, and 3 can be thought of as 3 over 1. So I'm going to think of this as 3 different fractions. And I need to find the common denominator. Now realize this is not the only method to solve rational equations. It is just one that works. So my LCD between the 3 fractions here would be, let's see, this denominator is a 1, this denominator is a 1, and this denominator is x minus 2. So the LCD is pretty simple for this problem. It's just the factor x minus 2. Step 2 in the equation says take note of any values of x that make the common denominator 0. So since my common denominator is x minus 2, the value of x that would make that denominator 0 would be found by just adding the 2 over. So x equals 2 is an x value that cannot be a solution to this equation. Because when you replace x with 2, you get a denominator of 0, and 4 divided by 0, or any number divided by 0 for that matter, is undefined. And since it's undefined, it can't make this a true statement. So what that means is when you get to step 5 and you check your work, if you happen to get a result of x equals 2, it wouldn't work. It wouldn't satisfy this equation. And you would see that at the end of this process. So it looks like I am on step 3. I found my LCD. I took note of any x values that would make the denominator 0. Now I'm going to multiply both sides of the equation by the common denominator. So my first fraction is just the number 1, and I need to multiply it by my LCD, which is x minus 2. And the next thing I need to do, since I'm multiplying both sides of the equation by x minus 2, is technically I'm taking the LCD of x minus 2 and I am multiplying it by the entire right-hand side of the equation. I never think of it this way, but that's what's happening. So what you really have here is the distributive property that shows that that factor of x minus 2 needs to get multiplied by not only this fraction, but also that fraction as well. So when I'm teaching this class, I typically don't do this more than once. I show them that when you multiply the right side by the LCD, that every term on the right side will get multiplied by the LCD. You don't get to play favorites. You have to multiply all fractions in the equation by the LCD, not just your favorite ones. So that being said, I typically jump right to this step, or I just say that every single fraction in the problem, I'll write all 3 of them down, will get multiplied by the LCD. Notice I'm leaving space here to multiply by my LCD in each fraction. In fact, I'm literally just going to copy that factor of x minus 2 and paste it in front of all 3 fractions. So not just the first fraction, but both fractions on this side of the equation. If it's helpful, I will put these fractions over the number 1 to remind you that this x minus 2 is in the numerator. So what's going to happen is this will clear the fractions, because any fraction that had a denominator of x minus 2, that factor will cancel with this factor of x minus 2, or better yet, any number divided by itself is the number 1. So what you really have is this simplifies down to be 4 times 1, but 4 times 1 is just the number 4. So oftentimes we say these cancel because all that's left is the number 4. These factors went away. I'm still left with 1 times x minus 2, but when you multiply by 1 in mathematics, it doesn't do anything. So we just have x minus 2. And then over here, don't forget that you will have to distribute that negative 3 to both terms inside the parentheses. So we have to do that yet. So we are on step 4 where we solve for x. But notice that we did accomplish what we wanted. We turned this problem that had a fraction involved in it and turned it into an equation with no fractions at all. So that was helpful. So first I'm going to distribute the negative 3 to both of the terms in the parentheses. Negative 3 times x is negative 3x. Negative 3 times negative 2 would be positive 6. I can combine like terms by saying that 4 and 6 combine to give you 10. In fact, I'll write it up here. And it doesn't matter if I write the 10 first or afterwards, as long as you make it positive 10. Now I have a choice. I can subtract 1x to bring it over to this side. That would make this number negative. Or I can add 3x to both sides, moving this to the left-hand side. That would leave my coefficient to be positive. So if that made sense, you'll see why I choose to add 3x to both sides, because I like to keep my coefficient on my x's positive, just my preference. So doing that, adding 3x to both sides, I get 3x and x add together to give you 4x. Still have the subtraction of 2. Negative 3x plus 3x is 0. We don't write addition of 0. And I'm left with positive 10 on the right-hand side. And I'm going to get right to it and solve for x by adding 2 to both sides. Negative 2 plus 2 is 0. 10 plus 2 is 12. The 4 is being multiplied, so I would divide both sides by 4. 4 divided by 4 is 1, so you have 1 times x, or just x on the left-hand side. 12 divided by 4 is 3. So this process has led me to the result of x equals 3. And if I didn't make a mistake, since the result I got isn't the number 2, it should check. Okay, so I've cleared the mess, and now I'm doing step 5, where I'm checking my solution, which is nothing more than copying the original equation and substituting the variable with my proposed solution, in this case 3. So replacing x with 3, the question will be, does this make a true statement or not? So let's see here. 3 minus 2 is 1. So we have 4 divided by 1 there. So 4 divided by 1 is nothing more than 4. So you're left with the statement 1 equals 4 minus 3. And of course, 4 minus 3 is indeed 1. So I get a true statement, which means that the result we got out of that algebraic process is a solution. What's more is it's the only number that will satisfy this equation.